In this particular video, we'll talk about the basics of I2C protocol. I2C stands for Inter-Integrated Circuit. It is a bus interface connection protocol incorporated into devices for serial communication. It is also known as two-wired interface or TWI. So just like the SPI protocol, I2C protocol is also a serial communication protocol and a synchronous communication protocol. So as you can see in the figure to your right hand side, the SCL stands for serial clock. And that is the clock which we are talking about when it comes to synchronous communication protocols. Now let us look into the working of an I2C communication protocol. I2C communication protocol uses two bidirectional open drain lines for data communication called SDA and SCL. What do we understand? We only have two lines over here, unlike the four lines in SPI. Now both these lines are initially pulled high. They are pulled high. Pulled high implies they are connected to a higher voltage level by the resistors which are shown over there. These resistors are known as pull-up resistors. Why are they pull-up resistors? Because they are connecting the line to a higher voltage, that is VDD voltage level. VDD is the higher end voltage. Now let's talk about the two lines. Serial data line, SDA line. The SDA line transfers the data from between the different devices. So this is the line where the data transmission is taking place. SCL line. It is basically the clock signal. This line will help us in order to synchronize the data and the transmission between the different devices. Now I2C generally operates in two modes. One is a master mode and the other one is the slave mode. Let us discuss a few properties about I2C. The data line cannot change when the clock line is high. In order for the data line to change, that is either go from high to low or to go from low to high, the clock line has to change first. A pull-up resistor is required so that the lines are high since the devices on the I2C bus are active low. What does this mean? I2C bus devices are active low implies that when the voltage level is on the lower side, at that particular point, the data communication and transfer will be taking place. Since we don't want the continuous data transmission and communication, we have to pull them to a higher voltage level, which offers a greater impedance with respect to the data transmission. So therefore, a pull up is required, and hence there are two pull up resistors connecting the two lines to the VDD. Data is transmitted in the form of packets. Why? Because it is a serial communication protocol, and as we discussed, it is transmitted in the form of packets, one after the other, in only one streamline of data. Now, every packet consists of 9 bits. We have to pay focus on it. Each packet comprises of 9 bits. One is the start bit. The first bit is the start condition bit. The other 8 bits are the slave address bit, and the remaining 1 bit is the acknowledgement bit. Now, let us just briefly look into the start and stop conditions of I2C. What do I mean by start and stop condition? Basically, when does the data transmission on an I2C protocol begin? What is the precondition for it? And what is the ending condition for it? In case of SPI, we understood the data transmission will start once the slave select line or the chip select line goes to a lower voltage level. That gives the master an indication that he has to set up communication with that particular slave. And that is how basically the communication begins. So similarly, we need to also understand what scenario or what situation in an I2C protocol will start the communication and what will end the communication. So the start condition of the I2C protocol goes as follows. The SDA line is changed from high to low while keeping the SCL line high. What is the stop condition? In the stop condition, the opposite thing happens. The SDA line goes from low to high while the SCL line is high. So this is how the I2C protocol data transmission starts and stops. Now there is another special feature that we need to look into, which are the repeated start conditions. But between each start and stop condition bus pair, the bus is considered as busy and no master can take control of the bus. If the master tries to initiate a new transfer and does not want to release the bus before starting the new transfer, it issues a new start condition. It is called a repeated start condition. So we talked about that the packet that is being sent needs to have 9 bits, right? So let's just look upon a couple of important types of bits which are present in that data packet. Number one is the read slash write bit. A high read slash write bit indicates that the master is sending the data to the slave, whereas a low read slash write bit indicates that the master is receiving data from the slave. ACK slash NACK, that is acknowledgement slash no acknowledgement bit. After every data frame follows an ACK slash NACK bit. If the data frame is successfully received, then an acknowledgement bit is sent to the sender by the receiver. Now, what are the important features of I2C communication? Number one, it's a half duplex communication protocol. Bidirectional communication is possible, but again, not simultaneously. Hence, half duplex. It is synchronous communication protocol. It can be configured for multi-master configuration. Now, this point is what stands out with respect to the SPI protocol. In case of SPI protocol, we had one master, one slave, one master, multiple slaves. But we never had multiple masters and multiple slaves. That is not possible in case of an SPI protocol. You can only have one master in case of SPI protocol. But in case of I2C protocol, you can have multiple masters and multiple slaves. This configuration is possible over here. There is another concept which is prevalent in I2C, that is clock stretching. I'll just briefly touch upon it. We won't go much into detail of it. The clock is stretched when the slave device is not ready to accept more data by holding the SCL line low, hence disabling the master to raise the clock line. Master will not be able to raise the clock line because the wires and are wired, and wait until the slave releases the SCL line to show its readiness for the transfer of the next bit. So, and basically another important point to be made over here is that I2C protocol is usually preferred for low speed communication. It is preferred for low speed communication because over here we have only single data line, that too half duplex, that too with a serial communication protocol category. So evidently the speed is going to be on the lower side. Example is an SD card.